Hello everyone, today we'll be going over A-Level Mathematics, October-November 2021, paper 5-3. This is paper 5 and we have a time limit of 1 hour and 15 minutes. So let's get started. For the first question, we're given there are 26 members of the local sports club include Mr. and Mrs. Khan and their son Abad. And the club is holding a party to celebrate Abad's birthday, but there is only room for 20 people to attend. In how many ways can the 20 people be chosen from 26 members? So we have the total member to be 26, and we're going to choose 20 out of those 26 members, right? Given that Mr. and Mrs. Khan and Abad must be included. So while choosing 20 members from the total of 26 members, we need to include these three members, Mr. and Mrs. Khan and Abad. So we're already choosing the three because they must be included. Then the remaining people to be chosen would be just 20 minus 3, which would be 17. And then the total number of members will also be reduced by 3, right? So that's going to be 26 minus 3, which gives us the total members of 23. Because the three members, Mr. and Mrs. Khan and Abad, is already included. So we just need to choose 17 people from the total of 23 members. So now the required number of ways is just going to be 23 C 17. Since we're choosing 17 out of the total of 23 members, this gives us the total of 100,947. So this concludes the first question. Let's move on to the second one. So we're given two schools, Lakeview and Riverside, and the pupils at both schools took part in a competition to see how far they could throw a ball. The distances thrown to the nearest meter by 11 pupils from each school are shown in the following table. So we're given the information right here. We need to draw a back-to-back stem and leaf diagram to represent this information with Lakeview on the left-hand side. All right, let's drop the stem and leaf diagram. So this is going to be the stem. Alright, so we want the Lakeview School to be on the left hand side, so that's going to be right here. And we want the Riverside to be on the right hand side. Alright, so let's look at the values that the stem can take. So we're going to look at the smallest value and the largest value. So for Lakeview, the smallest value of the stem is just going to be 1 and the largest value is going to be 4. And for Riverside, the smallest value is 1 again and the largest value is going to be 3. So the values on the stem is just going to be 1, 2, 3, and 4. Alright, now let's fill up the leaves. Let's do for Lakeview first. So the numbers having 1 as its stem is just going to be 10, 14, 19. So that's going to be 0, 4, and 9. Now we're going to repeat the same process for Riverside. So for the numbers having stem value 1, that's going to be 18, another 18. That's it. So that's going to be 2 8s. Now for the stem having the value of 2 for Lakeview, that's going to be 22, 26, 27, and 28. So that's going to be 2, 6, 7, and 8. Now repeating the same process for Riverside, that's going to be 23, 21, 25, 20, and 24, and 25. Alright, but we need to arrange it in an increasing order. So that's just going to be 20, 21, 23, 24, 25, and again another 25. So that's going to be 0, 1, 3, 4, 5, and another 5. Now for the values having stem 3 for Lakeview, that's going to be 30, 32, and 33. So that's going to be 0, 2, and 3. Repeating the same process for Riverside, that's going to be 36, 37, and 30. If you arrange it in an increasing order, that's going to be 30, 36, and 37. So that's 0, 6, and 7. Now for the stem with the value of 4, for Lakeview, that's going to be 41. We've already concluded that the highest value in the stem for Riverside School is going to be 3. So there are not going to be any values on the last row for Riverside. Whereas for Lakeview, that's just going to be 41. So that's going to be a 1. Alright, but we should also include the key for the stem and leaf. So that's just going to be, I am going to take this as my key. So that's going to be 2, 2, 0. And this means 22 meter for Lakeview and 20 meter for Riverside. Alright, let's move on to the second part. So we need to find the interquartile range. And interquartile range is just going to be the upper quartile, which is the Q3, minus the lower quartile, which is the Q1. So in order to figure out the interquartile range, we first need to figure out the values for upper quartile and lower quartile. And we're looking at the values for the Lakeview School, and the total number of samples n is going to be 11. So let's look for the value of lower quartile first. So that's just going to be n plus 1 by 4th item. And we already know n has a value of 11. And 11 plus 1 is 12. 12 divided by 4 is just going to be 3. So the lower quartile is just going to be the third item for the Lakeview School. So that's just going to be first, second, third. So that's 19 meters. Let's look for the value of upper quartile now. So that's going to be 3 by 4 into n plus 1 item. So n already has a value of 11. 11 plus 1, that's going to be 12 into 3 by 4. That's going to be the 9th item. So this is the third item. This is the 4th, 5th, 6th, 7th, 8th, and 9th. So the value for the upper quartile is just going to be 32 meters. And now we can easily figure out the interquartile range. Let's just plug in the values for the upper quartile and the lower quartile. So that's going to be 32 minus 19, which gives us the interquartile range of 13 meters. This concludes the second question. Let's move on to the third one. The times taken in minutes by 360 employees at a large company to travel from home to work are summarized in the following table. So we're given the time and we're given the frequency, and we need to draw a histogram to represent this information. So always remember, while drawing a histogram, the x-axis is going to be the range, which is time given in minutes in this case, and the y-axis is just going to be the frequency density. Now in order to figure out the frequency density, we first need to figure out the class width, and then the frequency density. Okay, I'm just going to write it here. So this is going to be the width, and this is going to be frequency density. And the formula for frequency density is just going to be frequency divided by the width. Alright, so for the first case, that's 0 to 5, which means that the width is just 5 minus 0, which is 5. For the second case, that's 10 minus 5, which is again another 5. For the third one, that's 20 minus 10, which gives us the width of 10. For the fourth one, that's 30 minus 20, again, that's 10. And for the last one, that's 50 minus 30, which gives us a width of 20. Now, we are already given the frequency, so we just need to divide these frequencies by their respective width. So for the first case, that's going to be 23 divided by 5, which gives us the frequency density of 4.6. For the second case, that's going to be 102 divided by 5, which gives us the frequency density of 20.4. Third case, that's 135 divided by 10, which is going to be 13.5. Fourth case, that's 76 divided by 10, which is going to be 7.6. And for the final case, that's going to be 24 divided by 20, which is going to be 1.2. All right, now we just need to drop this information in the form of a histogram. In order to do so, I'm just going to drop the axis first. So let's drop the x-axis. So this is going to be times in minutes. So the highest value for time that we're given in the question is 50. So I'm just going to mark it up. So this can be 10 minutes. This can be 20, 30, 40, and 50. All right, now we need to drop the y-axis. And the largest value that will be in the y-axis is going to be 20.4. All right. So I'm just drawing up the histogram freehand right here, but make sure you guys use a scale in an exam. All right, so the y-axis is going to be frequency density. All right, let's mark it up. So this can be 5, 10, 15, 20, this can be 25. All right, so for the first one, we have the range of 0 to 5, and for this we have the frequency density of 4.6. Let's draw it up. So we have the we have the x-axis as 0 to 5, so 5 is going to be right here, and we have the value of 4.6. so this is 1, 2, 3, 4 is right here, which means that 4.6 is somewhere around here. All right, let's move to the second one. So that's the range of 5 to 10, and we have the value of 20.4. So we have 20 right here, which means that 20.4 is somewhere around here. All right. All right, for the third one, the range is 10 to 20, and we have the frequency density to be 13.5. So, okay, 15 is right here, which means that this is 14, this is 13, and we have 13.5 to be right here. And we have the range from 10 to 20. So that's going to be it. Now for the fourth one, we have the range of 20 to 30 with the frequency density value of 7.6. So we have 10 right here, which means this is 9, this is 8, this is 7, 7.6 is somewhere around here. And we have the range to be 20 to 30. So wait. All right, now for the final one, we have the range 30 to 50, and the frequency density is 1.2. All right, so this is 1, so 1.2 is just slightly higher than that. And we have the range of 30 to 50. So this completes the histogram. Again, make sure you guys use a scale and not draw it freehand. So let's move on to the second part. we need to calculate an estimate of the mean time taken by an employee to travel to work. All right, let's first note down the range, and this is going to be the time. So the first one was 0 to 5, second one 5 to 10, third one was 10 to 20, 20 to 30, and 30 to 50. All right, now let's write down the mid values, which I'm going to denote it as M. Now, if we're talking about a range A to B, and we need to figure out the mid value, that's just going to be A plus B by 2. All right, so for the first case, that's going to be 0 plus 5 by 2, which gives us a mid value of 2.5. For the second case, that's going to be 5 plus 10 divided by 2, which gives us the value of 7.5. For the third case, that's going to be 10 plus 20 divided by 2, which is 15. 20 plus 30 divided by 2, which is going to be 25. And the last one is going to be 30 plus 50 divided by 2, which is 40. All right, now we have the frequency. This is just going to be listed from the question given above. So the first frequency was 23, then we had 102, 135, 76, and 24. Now we need to figure out the value of the mean. And in order to do so, we require the values of FM. So this is just going to be the product of these two columns. So the first one, that's going to be 2.5 into 23, which gives us the value of 57.5. For the second one, that's going to be 7.5 into 102, which gives the value 765. Third one, that's going to be 15 into 135, which gives the value of 2025. Fourth one, that's going to be 25 into 76, which gives us the value of 1900. And the final one is going to be 40 into 24, which gives us the value of 960. Now we need to figure out the sum of this column. So that's going to be 57.5 plus 765 plus 2025 plus 1900 plus 960, which gives the total of 5707.5. All right, we can also just sum up the column for the frequencies, so we get summation F, although this is already given in the question as 360. Now we can easily figure out the mean value. We know the formula to be summation Fm divided by summation F, and we have the value for both of these figures, so that's going to be 5707.5 divided by 360, which gives us the value for the mean as 15.854. This concludes the third question. Let's move on to the fourth one. So Raj wants to improve his fitness, so every day he goes for a run. The times in minutes of his runs have a normal distribution. Alright, so I'm just going to denote X as the time in minutes of his runs. His meaning Raj, so his runs. And we're given that it follows a normal distribution. And we're also given the parameter mean 41.2 and the standard deviation 3.6. So that's going to be 41.2, comma 3.6 squared, because the second parameter is going to be that of the variance. Now, for the first part, we need to find the probability that on a randomly chosen day, Raj runs for more than 43.2 minutes. So that's just the probability. X is greater than 43.2 because we're talking about more than 43.2. Alright, since we already know that X is a normal distribution, the first step would be to standardize. And whenever we're standardizing the normal distribution to a standard normal form, that's going to be Z equals to X minus mu, which is the mean, divided by sigma, which is the standard deviation. And we have the X value as 43.2 here, so that's going to be 43.2 minus the mean value is 41.2, so that's 41.2 divided by the standard deviation, which is 3.6. So we get the standardized value to be Z is greater than 0.556. Alright, so since we've completed the first step, the second step would be to drop the probability distribution. So this is going to be the mean value of 0, and we're talking about z having a value greater than 0.556. So 0.556 is somewhere around here, and we want the greater portion. So we require the probability for this shaded area. We know that in the normal distribution table given to us in the formula, we can only figure out the values lesser than a certain number. So we can figure out the probability less than 0.556, right? But we need to find the probability more than 0.556. In order to figure out this probability, we can just subtract this lesser portion, right? We can completely subtract this portion from the total probability. And we know that the total probability is always going to be 1. So we can just write it down as 1 minus probability of z is less than 0.556. Now, in order to figure out this portion, we have to look into the normal distribution table. Alright, so we're looking at the z value of 0.556. So 0.5 is right here, 0.55 is right here, so that's 0.7088. But we also have the third decimal place to be 6, which is given in this column, and the corresponding number is going to be 20. So we need to add this number to this probability. So that's going to be 0.0020. Let's add it up, which gives us the final required probability of 0.7108. Now we're going to substitute this value of 0.7108. All right, let's substitute the value. So that's going to be 0.7108. This gives us the probability of 0.2892. If we are to round it off to 3 figures, that's going to be 0.289. Let's move on to the second part. We need to find an estimate for the number of days in a year, all right, on which Raj runs for less than 43.2 minutes. So first, let's just figure out the probability that Raj runs for less than 43.2 minutes. Now, if we look back at the first question, we figured out the probability for which Raj runs for more than 43.2. So if the probability of him running more than 43.2 is going to be 0.2892, then the probability that he runs for less is just going to be 1 minus 0.2892. So that's going to be 1 minus 0.2892, which gives the required probability to be 0.7108. Now we need to figure out an estimate for the number of days in a year. So we need to figure out on how many days in a year does Raj runs for less than 43.2 minutes. If we're just looking at the sole probability, so this just gives the probability in a day, in a single day, but we're looking at the estimate for the probability in an entire year, right? So in order to figure out the estimate, we just need to multiply this probability with the total samples. So that's going to be 0.7108 into, and the sample we're taking is a year, which has 365 days. So that's going to be 365. Now this gives us the required estimate for the number of days in a year to be 259.442. Since we're talking about days, we need to round it off. We can round it off as 259 or 260. Let's move to the third part of this question. We're given on 95% of days, Raj runs for more than t minutes. So this is just going to be the probability. So we're given that probability of Raj running for more than t minutes is going to be 95%, which can be written down as 0.95. Now, since we already know that x follows a normal distribution, the first step would be to standardize. So that's going to be z is greater than t minus the mean value, which is going to be 41.2, divided by the standard deviation, which has a value of 3.6. This is equals to 0.95. All right, let's move on to the next step. That would be to drop the probability distribution. All right, so this is 0. And we're looking at the z value of t minus 41.2 divided by 3.6. And the probability greater than this value is going to be 0.95. And since we know that the probability to the right-hand side and the left-hand side of the mean, which is 0, is just going to be 0.5 and 0.5, this suggests that this value is going to lie on the left hand side. So that's going to be somewhere around here. That's going to be t minus 41.2 divided by 3.6, and the probability greater than this is going to be 0.95. Now if we were to use the symmetricity property and just completely flip this figure, that's going to be something like this. So this is 0. If there is t minus 41.2 divided by 3.6 on the left hand side, then there is also going to be 41.2 minus t divided by 3.6. This is because if there's a number minus a on this side, then that's going to be positive a on the right hand side, right? So we're just changing the sign, and that's going to be 41.2 minus t. And then the probability less than this value, due to the symmetricity property, this is just also going to be 0.95. So we're looking for the z value for which the probability less than that is going to be 0.95. So we're looking at the standard value of 0.95 that is given on the smaller table at the end of this page. So we're looking at the probability of 0.95 and we're trying to figure out the corresponding z value, which is given to be 1.645. So we're just going to substitute this value. So we just figured out that the corresponding z value for the probability of 0.95 is going to be 1.645, which means that this is equal to 1.645. Now, in order to figure out the value of t, we can just solve this equation, right? So that's going to be 41.2 minus t divided by 3.6. That's going to be 1.645. This means that 41.2 minus t is going to be 1.645 into 3.6. Now, if we were to bring t to the other side, that's going to be 41.2 minus 1.645 into 3.6 equals to t. So this gives us the final value of t to be 35.278. This concludes the fourth question. Let's move on to the fifth one. A security code consists of 2 letters followed by a 4-digit number. So we're looking at 2 letters and then 4 numbers. And the letters are chosen from A, B, C, D, E. To choose these 2 letters, so we have the option of A, B, C, D, and E. And in order to choose these 4 numbers, we have the option 1, 2, 3, 4, 5, 6, and 7. Alright, no letter or digit may appear more than once, so we cannot repeat the letters or the digits. An example of a code is BE3216. Now we need to figure out how many different codes can be formed. So we're talking about specific arrangements, right? We're looking at the positions of the letters and the numbers, and whenever we're talking about position, we always use permutation. So permutation is just P. Now for the first part, that's the letters, right? And we are to choose 2 letters from the total of 5. So, okay, number of codes is just going to be, out of the 5 letters, we need to choose 2 letters. So, and we're also considering their positions, which means we're going to use the permutation. That's going to be 5p2 multiply, and we're talking about 4 numbers, which we are to choose from the total of 7 numbers. So that's just going to be 7p4. Permutation again, because we're also considering the positions for the different numbers. So this gives us the total number of codes to be 16,800. Let's move to the second part. We need to find the number of different codes that include the letter A or the digit 5 or both. Alright, so whenever we're talking about the number of different arrangements in which these letters or numbers should be included, it is easier to figure out if you just figure out the total number of different codes, which we already did in the first part, and then subtract the total number of different codes that does not include the given conditions. So in this case, that will be the number of different codes that do not include the letter A and the digit 5. So we're going to figure that out first. So that's going to be number of codes excluding letter A and the digit 5. Alright, so we need to choose 2 letters from the total of B, C, D, and E. So that's just 4 because we're excluding A. So we're choosing 2 letters from the total of 4 letters, which is just going to be 4P2. We're using permutation because we're considering the positions or the specific arrangements of these letters. Multiply, the second part would be that of the digits, and we need to choose 4 digits from the total option of 1, 2, 3, 4, 6, and 7. So that gives us the total option of 6, right? And we are to choose 4 digits from the possible 6 digits. So that's going to be 6P4. Again, we're using P permutation because we're also considering the specific positions or the arrangements. So this gives us the total number of codes excluding A and 5 to be 4,320. Now we need the number of codes including A or 5 or both. Now, as I said before, for this we just need to subtract the number of codes excluding A and 5 from the total number of codes without any restrictions, which we figured out in the first portion. And the value we figured out was 16,800. So we just need to subtract the value we just figured out. That's going to be 4,320. This gives us the final answer to be 12,480. Let's move on to the third part. A security code is formed at random. Find the probability that the code is DE followed by a number between 4,500 and 5,000. Alright, this is a bit tricky. So we're looking at the probability, so let's just multiply the probability for each letters or numbers. Alright, so for the first part, that's the letters, we have the letters to be D and E. So required probability So this is going to be for D, we're choosing D from the total of 5 letters, right? So that's just the probability 1 by 5 multiplied. What we know is that the letters cannot be repeated, which means that we had the option to be A, B, C, D, and E for the first one, but we already selected D. So we cannot select it again, which means that the total remaining options now is going to be 4. So the probability of choosing E from these 4 possible letters is just going to be 1 by 4. So that's going to be 1 by 4. Now for the numbers, we need the number between 4,500 and 5,000. So we're choosing 4 numbers. If we are to choose a number between 4,500 and 5,000, then this position is going to be 4, right? And we're choosing 4 from the possible digits of 1, 2, 3, 4, 5, 6, and 7, which means that the probability of choosing a 4 from the given 7 options is going to be 1 by 7, right? Then for the second letter, we are to choose a number between 4,500 and 5,000. So the possible digits for the second place is going to be 5, 6, or 7. So these are the 3 possible digits that we can choose. And since we know that we cannot repeat the digits, since we already chose 4 for the first place, we no longer have it as our option. So our options reduces to 6 digits, and out of these 6 digits, we need to choose 3 of these. So that's just the probability 3 by 6. Then for the third position, we can choose any of these letters except for we already selected 1, right? So let's just exclude 1. Then we have the remaining options to be 5. And out of these 5 digits, we can choose whichever digit. So that's just going to be 5 by 5. And since we already selected a digit here, it again reduces our option. So for the last place, we can choose any of the digits from the remaining 4 digits. So that's just going to be 4 by 4. So that's it. We can just multiply this and get the required probability to be 1 by 280. This concludes the 5th question. Let's move on to the 6th one. In a game, Jim throws 3 darts at a board. This is called a turn. The center of the board is called the bullseye. Now the random variable x is the number of darts in a turn that hit the bullseye, and the probability distribution of x is given in the following table. And we are to find out the values of 2 variables p and q. So whenever we're talking about the number of variables that we need to figure out the values for, we need to first find the same number of equations. So we have two different variables here, right? Which means that we need to first figure out two different equations, including these two variables. Alright, so the first equation, we can just figure it out from the probability distribution table, since we know that the total of these probabilities should be equal to 1, right? So the first equation is just going to be 0.6 plus p plus q plus 0.05 should be equal to 1. This is p plus q equals to 1 minus 0.6 minus 0.05. Let's move q to this side. So that's going to be p is equal to 0.35 minus q. Now for the second equation, we're going to use the information for the expectation. So we know that the expectation of x is just going to be summation of x along with its product to the respective probability. So in this case, that's going to be 0 into 0.6 plus 1 into p plus 2 into q plus 3 into 0.05. This is equals to 0.55. Alright, so that's just p plus 2q equals to 0.55 minus 3 into 0.05. So that's just going to be p plus 2q equals to 0.4. Now we can just substitute the value for p from the first equation. So this is going to be 0.35 minus q plus 2q equals to 0.4. Solving this, we get 0.35 plus q equals to 0.4. Then q is just going to be 0.4 minus 0.35. This gives us the final value of q to be 0.05. Now in order to figure out the value for p, we're just going to substitute this value. So p is going to be 0.35 minus 0.05, which gives the final value for p to be 0.3. Let's move to the second part. We need to figure out the variance of x. Alright, so the variance of x is just going to be expectation of x squared minus expectation of x whole squared. So we already have this figure given in the question. We need to figure this value. So expectation of x squared is just going to be summation of x squared into its respective probability. So this is just going to be 0 squared into 0.6 plus 1 squared into 0.3 plus 2 squared into 0.05 plus 3 squared into 0.05. So this gives us the expectation of x squared to be 0.95. Now let's just substitute the values. This is going to be 0.95, and we know expectation of x to have the value of 0.55. We need to square it, which gives us the final variance of 0.6475. Let's move to the third part. Jim is practicing for a competition and he repeatedly throws 3 darts at the board. Now we need to find the probability that x equals to 1 in at least 3 of the 12 randomly chosen turns. Alright, so now this transforms into a binomial distribution. And for the binomial distribution, we have the first parameter to be the number of samples, which is 12. And then the p in this case is going to be probability of x equals to 1, which we figured out in the first part as 0.3. So the probability is just going to be 0.3. Now we need to figure out the probability that x equals to 1 in at least 3 of the 12 turns. So that's going to be greater or equal to 3, right? And since we have the sample of 12, so the possible values would be 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12. We need to figure out x greater or equal to 3. So we need to figure the probability for these numbers. But this is a lot of calculations. It would be easier if you just had to figure out these 3. We can do that by subtracting this probability from the total probability of 1. So that's just 1 minus probability of x equals to 0, 1 or 2. Now we use the binomial formula in order to figure out these probabilities. A reminder here that I denoted it with the same variable given in the question. It would have been easier if we were to denote it with y, if you get confused. So let's use the binomial distribution formula. So this is just going to be 12c0 into 0.3 to the power 0 into q. So if we have the value of p to be 0.3, then the value of q is just going to be 1 minus p, which is 0.7. So 0.7 to the power 12 minus 12c1 into 0.3 to the power 1 into 0.7 to the power 11 minus 12c2 into 0.3 squared into 0.7 to the power 10. Alright, so I'm going to write these probabilities in 4 decimal places. So that's going to be 1 minus 12c0 into 0.3 to the power 0 into 0.7 to the power 12 is going to be 0.0138 minus 12c1 into 0.3 to the power 1 into 0.7 to the power 11 is going to be 0.0712, and the final one, 12c2 into 0.3 squared into 0.7 to the power 10 is going to be 0.1678. So this gives us the final probability to be 0.7472. Now if we want to round it off to 3 figures, that's going to be 0.747. Let's move on to the fourth part. Find the probability that Jim first succeeds in hitting the bullseye with all 3 darts on his 9th turn. So the probability of hitting with all 3 darts is just going to be probability x equals to 3, which is given in the question in the form of probability distribution table, which has the value 0.05. But we only want Jim to succeed on his 9th turn. So this just automatically transforms into a geometric distribution now, right? So we have 6, 7, 8, 9 turns, and we only want him to succeed here, which means that for the first 8 turns, there needs to be a failure. And the success is only at the last turn. So the required probability is that we want failure for the first 8 turns, and we know that the success probability is 0.05, so the probability of failure is just going to be 1 minus 0.05, which is 0.95. Alright, but we want the failure to be 8 times, so we just have to put the power 8, and we finally want the success on the 9th turn, which we will multiply by the probability of success, which is 0.05. This gives us the required probability to be 0.033. This concludes the 6th question. Let's move on to the 7th one. Box A contains 6 red balls and 4 blue balls. Box B contains X red balls and 9 blue balls. A ball is chosen at random from box A and placed in box B. Alright, a ball is then chosen at random from box B. We need to complete the tree diagram below, giving the remaining 4 probabilities in terms of x. So we know that the ball is chosen from box A and placed in box B. Now, if we are considering choosing red ball from box A and putting the red ball in the box B, then box B will contain now x plus 1 red balls and 9 blue balls, right? And out of these balls, the probability of choosing red is just going to be x plus 1 divided by x plus 1 plus 9, which is just going to be x plus 10. Now for the blue one, this is going to be 9 divided by x plus 1 plus 9, which is 10. But if we are considering choosing the blue ball from box A and putting it in box B, then box B is going to have x red balls and 9 plus 1 blue balls, which is going to be 10 blue balls, right? And now if you are to choose a red ball from box B, that's going to be x divided by x plus 10, And if we are to choose blue ball, that's going to be 10 divided by x plus 10. This completes the tree diagram. Let's move on to the second part. We need to show that the probability that both balls chosen are blue is 4 divided by x by 10. So both balls chosen are blue. So this is just going to be this portion, right? Blue and blue. We need to multiply these two probabilities. So required probability this is just going to be the product of these two probabilities, which is 4 by 10 into 10 by x plus 10. We can cancel the 10 and 10, which gives the required probability to be 4 by x plus 10. This completes the second part. Let's move on to the third one. Now it is given that the probability that both balls chosen blue is 1 by 6. So this is given so that we can figure out the value for x. From the second part, we figured out the probability to be 4 by x plus 10, and now we're given that this probability is equal to 1 by 6. Let's just solve this equation. So that's going to be 4 into 6 equals to x plus 10. In order to figure out the value for x, that's going to be 4 into 6 minus 10, which gives us the value of x to be 14. Alright, now we need to find the probability correct to three significant figures that the ball chosen from box A is red. So ball chosen from A is red, given that the ball chosen from B is again red. So using the formula for Bayes' theorem, this is just going to be ball chosen from box A is red and ball chosen from box B is red, divided by the probability that the ball chosen from box B is red. Okay, this is going to be a little lengthy. Let's first figure out the value for the denominator. So that's going to be ball chosen from box B is going to be red. We have two different possibilities. We can either choose red from box A and then red from box B, or we can either choose blue from box A and red from box B. So that's going to be 6 by 10 into x plus 1 by x plus 10 plus 4 by 10 into x divided by x plus 10. Okay, so this is going to be, first is it can be red and red. So that's 6 by 10 into x plus 1 by x plus 10, or it can be blue and then red. That is 4 by 10 into x divided by x plus 10. Let's substitute the value for x. We already figured out it to be 14. So that's 6 by 10 into 14 plus 1, that's 15. 14 plus 10, that's 24. Plus 4 by 10 into 14 by 14 plus 10, that's again 24. Now this gives us the total probability of 73 by 220. Alright, now we need to figure out the probability for the numerator portion. So that's just, first one, it's going to be red chosen from box A, and again we are to choose red from box B, which is just given by the first portion. So it's just this value, which is 6 by 10 into 15 by 24. Let's figure out the value for the numerator as well. So that's just going to be 6 by 10 into 15 by 24, which gives us the total probability of 3 by 8. Now let's just substitute these values. So that's just going to be 3 by 8 divided by 73 by 120, which gives us the required probability of 0.616. Alright, this brings us to the end of this question, and it also brings us to the end of this set. If you found this video useful, make sure you hit the like button, make sure to leave a comment below, and make sure you subscribe and hit the bell icon so that you do not miss any of my videos in the future. Thank you.